Another type of code injection vulnerability in web applications are SQL injections. So if you look at the typical workflow of a web application, what an attacker is actually interested in is usually the database. Because the database contains user information, credit cards, passwords, whatever. So usually the interesting information is located in a database, and this information might be valuable for an attacker. This is why SQL injections are usually as critical as remote code execution. So if you're just sitting in front of your computer logging into a website, you usually have a login form like this one. How could this be implemented? Well, here's an example in PHP. So we take the username and the password from a post request from the login form. Then we do a SQL request to the MySQL database backend and select everything from users where the user name is equal to the user that was supplied and the password is equal to the password that was supplied here. And then we check if there's a result. Then the user is logged in, because obviously there was a database row that had the user like this and the password like this. And in case there's no result, then we say, okay, these credentials are obviously wrong and the user is not logged in. Why is this a problem? Well, what about if we would set the user to this string? Well, what would happen? Well, we have the query here, and now we set the username to these characters. Well, the apostrophe terminates the string. Now the string is over. Now we can write SQL. And we write or 1 or 1. And this is always true, obviously. This statement here is always true, because or 1 or true is always true. Then there come the hashtag, the Raute, and everything behind the hashtag is a comment in SQL. So everything here behind the hashtag will be ignored. So since this query is always true, here we will always get a result, because the database here will just return the first row of the database. So we bypass the login.